So similar to the Egyptian numerical system, the Attic numerals developed in Attica, the area surrounding Athens, also base 10. All right. So you have iota for one, delta, eta, chi, and mu. All right. Also a base 10 system, so the ones place, and I neglected to mention this in the previous video, but in terms of the places that make up a value, the ones place has one numerical value. But if we're calling this base 10, that's really the same as saying 10 to the 0th power. Okay, 10 to the 0th power is equal to 1, 10 to the first power is equal to 10, 10 to the second power is equal to 100, to the third, and to the fourth power, 1,000 and 10,000 respectively. Right? And if you think about it in terms of how many zeros are in the number, right? There are 0 zeros in the number 1. There is 1 0 in the number 10, 2 zeros in the number 100, and so on. That kind of gets you to the basis of this base 10 system. All right. Here we're just really designated just along the same lines of what we did with the Egyptian numerical system. We're going to represent it using these, really we'll just call them symbols, right? Because whether I call it a coil or an eta, it really doesn't make a difference. Special symbol for 5 was also used, right? Penta, meaning 5. So that allowed us to come up with multiples of 5, right? So if you take, and it's kind of fun to look at, but also it makes a certain amount of sense when you recognize that the composite symbol for 50 has that penta. All right, so penta is sort of like a little hangman, and the value for 10. All right, so you tuck in a little 10 here. All right, and you have the symbol for 50. All right, so really you're just taking whatever the base 10 symbol is. So for 500, you have that little, we'll call it H, but it's really the eta, the chi, and the mu. All right, all tucked in to the little nook there associated with the initial letter of penta. All right, so if I want to write something like 852 in Attic Greek, I can break it up based off the digits. I have 8 of those 100s, all right, and the 100 I'm using the eta symbol, all right. So I'll just kind of sort of do it off on the side here. So I have, it's kind of strange, 8 of those. I'll use my little multiplication. 8 of my etas. It's kind of fun to say. 5, and the symbol that I'm using there is a delta. 5 of the deltas, plus 2 of the iotas. Right. So really just ones. They get like little tiny eyes. Little tiny horizontals to represent the eye. All right. So we could do it that way. All right. But if we know that the 50 can be also written as the penta associated with the delta, if I can actually make it look halfway decent. All right. We would have our 2 iotas. And then for the 800, our composite symbol for 100, so we have the eta mixed in with the penta. That'll get me to 500. All right, so if I look at this as saying 5 hundreds plus 3 hundreds, if I do a penta with an eta inside, all right, again, the eta is the H looking thing, then I would have 3 of those that can't be really regrouped, so 3 more etas. I'd have the penta delta and my 2 iotas all together would make up the expansion of 852 in Haddon Creek. Okay. So example 2 is along the same lines. 2 of those thousands, 8 of the 100s. You could say 5 of the 10s if you want, and 7 of the 1s, but again, you could also think of this as the penta delta, right? And the idea with the 800, same as what we did up here, this would make up 800, so that's going to correspond with this. We only have 2 of the thousands, all right, so 2 of the chis. If I had 11 of the chis, then I'd be looking to regroup and maybe incorporate a mu, but not the case here. And then for the 7, we could look at it as 7 ones, but I could also look at it as 5 plus 2. And so we have a penta, and then another 1, 2. All right, so that would get me to this part of it. All right, so some of it we had already done, some of it, we had to kind of figure out as we go. All right, going the other way, translating it into a numerical system. So again, it's easy enough to say, but as long as you know what everything represents, you're fine. But this is a 5, a 1. We have a 50 here. All right, we have the delta, that's worth 10, a penta delta. So 5 of the 10s is 50. All right, my chis are each worth 1,000. So that's, sorry, my squiggly bracket game is a little off. So that's going to give me 4,000. All right, I'm going to have 2 of the 10,000s, so 20,000. Then we have the penta with a chi. All right, so again, a chi is 1,000. So if I'm looking at 5 of those thousands, then this symbol here is worth 5,000. So put it all together, 20,000 plus 5,000 plus 4,000 plus 50 plus 5 plus 1. The 5 and 1 get me a 6. The 5,000 and the 4,000 get me a 9,000, and everything else is just kind of as is. All right. So if I know my mu is worth, so this is 5 10,000s. This one here is 5 1,000s, and this is 5 hundreds. That pretty efficiently gets you where you want to know. Where you want to go. All right. And that would be, I think, to exercise set 1.1.2.